Hello everyone, welcome to the world of data structures. Our today's topic is B-tree insertion or insertion in B-tree. Hi, this is your instructor Janish Shah. So let's begin with the outlines. Students, for today's outlines, the first we'll talk about the rules for the B-tree insertion. Then we go on the short overview of B-tree properties. Okay, and then we'll see the example of B-tree insertion. So let's start with the first rules for the B-tree. Okay, so students, the insertion takes place in B-tree from the leaf node. Actually, the thing is that whenever you want to perform any operation on B-tree, it must be start from the leaf node. And here, always remember that insertion and deletion starts from the leaf node. So what you need to do is, to insert an element, first you need to find the appropriate leaf node and then do insertion on that element. Okay, so what we need to do is, we just need to find out the first appropriate the leaf node or the position of the node where we need to insert our new element. But for insertion, we have two different cases. First, case number 1. Suppose students, if you have enough space in your leaf node. Okay, so the first case number 1 is that if you have enough space in your leaf node, then you have to insert the values in the ascending order. And we all know that in B-tree we are just inserting the data in ascending order. Okay, and then the case number 2, if there is no space in the leaf node, then what to do? So the before insertion, you need to find out the middle element. Okay, so before insertion, I'm just finding out the middle element from the leaf node. I'm just taking that node, okay, on the up level or on the parent node. Okay, so take out the node middle element from the leaf node, bring it to the parent node and insert your data and split the node from the middle point. Okay, so how we can go in this case too, we will understand better in our next example. Now, here are the overview of rules of the B-tree properties. Okay, so the first property is that insertion and deletion starts from the leaf node. Then we have the lesser values from the node are situated on the left side and the greater values from the node are situated on the right side. Then students, all leaf node are at same level. See, in B-tree, if you are going to perform insertion operation or deletion operation, after performing the operations, students, all leaf nodes are at same level. Okay, so there is no chances of unbalanced tree over here because your tree obviously a balanced tree. So students, these are the basic properties of the B-tree that we have already seen in previous session, that the root node, in root node, the minimum subtrees are 2 and maximum subtrees are m. Students, we know that the subtrees means number of child or number of pointers. Fine. Now, the internal node must contain the minimum subtrees ceiling of m by 2 and the maximum subtrees m. What about the leaf nodes? Students, in leaf node, we do not have any subtrees or any child nodes. That's why we'll talk about the values in leaf node. So, the minimum values in leaf node are ceiling of m by 2 minus 1 and the maximum values must be m minus 1. Fine. So, here let's start. Just taking the example, suppose if your B-tree has order 4. Suppose you have m is equal to 4, that means order is equal to 4. Then students, your root node should contain minimum subtrees 2, maximum subtrees 4. Your internal should contains minimum subtrees 2, maximum subtrees 4, and your leaf node should contain minimum values 1 and maximum values 3. Okay, sir, minimum values, why? Because this is a leaf node, it does not contain any subtrees. Okay, fine. Okay, so what about the next? If the order is equal to 5, okay, just taking the example that if m is equal to 5, then what are these nodes? Okay, so root node must contain the minimum subtree 2, maximum subtree is 5. root node must contain minimum subtree is 2, maximum subtree is 5. Internal node must contain minimum subtree is 3. Just put your formula over here. Put m is equal to 5 in this formula and get your answer. That ceiling of m by 2, that means 2.5, and that ceiling value becomes 3. That's why students, the minimum subtrees are 3, okay, and maximum subtrees are 5. And in leaf node students, the minimum values is 2 and maximum values are 4. Fine. So let's start with the examples of B tree students. So here the order is equal to 4, so order is already given. So I am just writing over here that how many elements are there in leaf node, root node and internal nodes. So students, we know that as the order is 4, students, the root node minimum contains 2, maximum 4. Internal node contains minimum 2 and maximum 4. But leaf node contains minimum 1 value and maximum 3 value. Those are for the root node and internal node. It must say about the subtrees. Okay. So values are subtrees minus 1. Now, here is the example. We need to insert these values in our B tree. Okay. So same as AVL tree insertion, or we can say same the binary search tree insertion. We are just starting from the very first value that becomes our root node. No, it must be in our root node. Fine. Okay. So here it is. Students, order is 4. So we can store how many values in each node? My question is that if my order is 4, then we can store how many values in each node? We can store, students, 3 values in each node. Okay. So here order is equal to 4. So students, we can store 3 values in each node. So here it is. This is my first value, that is 66. This is my first value. Okay. This is my first element in root node. Now tell me, you have to, students, just draw like this, like element over there, and 2 pointer spaces must be also over there, one for left, one for right. Okay. Now what is the next value? What is the next value, students? The next value we have 90. The next value we have 90. Okay. So what we need to do is, we just need to insert 90. Now tell me, this is our first node. Okay. Here B tree is of order 4. That means, students, each node must contains maximum 3 values. Maximum 3 values. So here we have just inserted only one value. That's why we can insert 90 over here, because there are still space are there to insert the new values. Fine. So what I need to do is, I am just going to insert 90 over here. But can you tell me the position of 90? It must be before 66 or after 66. It must be before 66 or after 66. It is after 66. Why? Because we are inserting the data in ascending order, and for that first we'll have 66 and then 90. So here it is, 90 with us. Okay. So 90 is successfully inserted. Okay. Now let's move further for the next value. There we have 40. There we have 40 with us. Okay. So students, tell me, 40 can be inserted at which position? Okay. Don't think much. Just put the value in ascending order. First check, is there any space or not? Before insertion, you need to check out whether there are space in node or not. 2 insertion rules. Case number one, that if there is a space, then you can insert the data according to the ascending order. Okay. So this is case number 1. We can directly insert 40 before 66. The whole term becomes 40, 66, 90. 40, 66, 90. Fine. Now, next we have 75 with us. Now students, tell me, can you have any space at the first node? Do you have any space in the first node? Yes or no? No. Why? Because the order is 4. So sir, we can insert maximum 3 values. Very good. So you can insert maximum 3 values and your node becomes full. So here your node is full. So what you need to do is case number 2. So just check the case number 2, students. Here my root node is full. Where I cannot insert any values. So what I need to do is, I just need to split my root node. I just need to split my root node from the middle of the term and then insert the value according to it. So where the middle term will go? Students, your middle term will go up level. Okay, fine. Let's see how. So here it is. See, the next students we have 66 is our middle term. From 40, 66 and 90, 66 is our middle term. So we can split from this 66. 66 will go one level up. Okay, there. Now on the left side of the 66 students, we must contain 40. On the right side of the 66 students, we must have 90. So this becomes our new tree. 66. Okay, what you did, you just split the 66 in that node in two parts. So what happens? The middle term will go one level up. One level up. So here it is 66 and these are 40 and 90. Here it is 66, these are 40 and 90. Fine. Now just try to insert 75. Students, here in B tree, you do not worry about the insertion from the starting from the root node, because each and every insertion starts from the leaf node. So now tell me, what is the actual position where I can insert the leaf node 75? Okay, how can we say, sir? It must be on left side of the 90. How we can say that? See, here insertion must starts from the leaf node. Okay, so here it is 90, 75 is greater than 66. 75 is greater than 66. So there must be on the right side of 66, where according to the, see, now check the 90 node. Check the 90 node. How many elements you can insert at that position? 3 nodes. You have only one node, that is 90. That's why, students, we can insert directly 75 over there, but on the left side of 90. On the left side of the 90. Okay, so this is my final answer after inserting 75. What I did first, before inserting the 75, just need to check whether my node is full or not. As my node is full, I need to split it down in two parts. The middle of the term will go one level up, and we have node, left node, right node with us. And when I'm going to insert the 75, I can check out that the 75 is greater than 66. 75 is greater than 66. That's why I need to go on the right side of the 66, where I found the 90, and 75 is less than 90. That's why it must be on left side of the 90. So here it is, 75 must be on the left side of the 90. Okay, now let's begin with the next value. Students, next we have 30 with us. Okay, now tell me where you can insert this 30. See, 30 is less than 66, we already know that. So we must go on the 40 node. Okay, so 30 is less than 40, that's why it must be on the left side of the 40. Okay, so insert a node starts from the leaf node. Okay, here on the leaf node, see, the leaf node we have 40 and 75, 90, and up level we have 66. 40, 75, 90, and the up level we have 66. So what we can do, students, we can insert 30. We can insert 30 on the left side of the 40. On the left side of the 40. So here it is. See, 30 can be inserted on the left side of the 40. Okay. So now 30 is successfully inserted. Okay. Moving towards the next value, students, we have 35. Next value we have 35. So again tell me where we can insert 35. Sir, there is a space at the 40 and 30 nodes. Okay, so on the left side of the 66, students, we have only two nodes. There are 30 and 40. 30 and 40. Now tell me, each and every node must contain maximum 3 values. Each and every node must contain maximum 3 values. Do we have enough space to insert the 35 at the node 40? Yes, we have. That's why we can insert 35 before 40, but where? Between 30 and 40. Between 30 and 40. Why? Because we need to insert the values according to ascending order. That's why insert the values from the leaf node. Here we have enough space between 30 and 40. That's why we can insert like this: 30, 35 and 40. This is my final answer after insertion of 35. Okay, now next we have 80. Students, on 80 where we need to check it out? Where we need to check out on the right side of the 66? Students, on the right side of the 66 we have 75 and 90. We have 75 and 90. So we have one space left over there. So we can insert 80 over there. See, this is my figure after insertion of 80 where 75, 80 and 90 are successfully inserted on the right side of the 66. Okay, now what next? Next we have 70. Okay, so students, next we have 70. Here for the 70, okay, you need to start the values insertion from leaf nodes. Okay, that's why 70 can be inserted on the right side of 66. 70 can be inserted on the right side of the 66, but on the right side of the 66, students, we already have 3 values in one node. Okay, this node, the right side or right child of 66 contains already 3 elements. Now tell me what is the order of this B tree? Students, the order of B tree is 4, so that we can insert maximum 3 values. Okay, we can insert maximum 3 values in leaf node. That's why what I need to do is, again I need to do a split operation over here, where I have to split node 80. Okay, take the value 80 one level up, take the value 80 one level up and connect it with the root node 66. So what I need to do is, here as the 70 need to be inserted before 75, 70 need to be inserted before 75, but the node is full. So what I need to do is, I just need to move 80 one level up with parent node. Okay, what is the parent node? That is 66. So students, 80 will go with 66. Now tell me, on root node do we have space? Yes, because only one element is there and we can insert maximum 3 values. We can insert maximum 3 values. Okay, so here it is. This is my figure. Okay, so see, here students, you can insert 80 on the right side of the 66, and then see, now 80 have 2 parts. One is less than 80, one is greater than 80. Okay, so 80's left pointer must point to the values which are lesser than 80. So students, 70 will go with the 75 and it will become the left pointer of 80, and on the right side of the 80 we have 90. Okay, so this becomes our new figure after inserting 70. So what we did, we just want to insert 70 over there, but there is no enough space, so I just need to move a middle term of that node to the parent node. Okay, on parent node students, we have 66, there is only one element is there. So what I need to do is, I just need to match, or I just need to connect 80 with 66, 80 with 66. Okay, and then there are 2 parts are there because 80 is gone. So now that node is divided into 2 parts. Okay, on the left side of the 80 we must contain the values which are lesser than 80. On the right side of the 80 we must contain the values which are greater than 80. Fine. So this is the figure after inserting 70. Okay, now next we have 20 with us. So what happens? Same as 70, here 20 does not have enough space so to enter in this node. See, check, on the left side of the 66 students we have 30, 35 and 40. 30, 35 and 40. So 20 must go over there, but it cannot be inserted. So what I need to do is, I just need to move the middle term to the parent node. Middle term to the parent node. Now tell me, what is the middle term of this node? That is 35. So students, 35 will go to the parent node. Okay, so I'm just taking it up, okay, and move towards the parent node, and it will be inserted with node 66. So now tell me, just you need to arrange the values in a node. Okay, here we have 35, 66 and 80 with us. So just arranging them in ascending order. So first we have 35, then 66 and then 80. Okay, here it is. Now the values which are lesser than 35 must be on the left side of the 35. That's why 20 and 30. 20 and 30 becomes on the left side of the 35, okay, and then the remaining terminologies that are 40. So 40 must becomes between 35 and 66. See the pointer, that the right side of the 35, the right side link of 35 and the left side link of 66. That shows this pointer contains the values which are greater than 35 but lesser than 66. Okay, that is 40, so 40 must be over there. Okay, now let's move further. Students, next we have value 50 with us. Now tell me where we can insert the 50. Okay, see, 50 must be inserted according to ascending order. So it is greater than 35. Okay, it must be less than 66. So you need to go on the leaf node 40. Leaf node 40, because 50 is greater than 35 but less than 66. So just you need to go at the node 40. So we can easily insert 50 on the right side of the 40. So here it is. Just insert a node on the right side of the 40. Okay. So 50 is successfully inserted on the right side of the 40 like this. Now the next value we have 45 with us. So students, tell me, next we have 45. So again 45 is greater than 35 and less than 66. You need to go on the leaf node 40, 50. Need to move towards the leaf node 40, 50. Now tell me, 45 can be inserted in between of 40 and 50. This is 40, this is 50, 45 can be inserted over here. Okay, so here it is. Students, if you can say how to insert the node 45. So 45 can be easily inserted between 40 and 50. Okay, so this 40, 50, 45 is inserted and the link is connected in between 35 and 66. Okay, so this is an insertion of 45. Now again move towards the next insertion. Students, the next insertion is 55. Now this is very important insertion. Okay, why? Okay, let's see. See, the value that we need to insert, that is 55. Now tell me where we need to insert over there. Students, we need to insert 55. 55 is the value that is greater than 35 but less than 66. So you need to move towards 40, 45 and 50 node. Now tell me, is there any space is still remaining to be insert a data on 40 node? No. Why? Because this tree has order 4, so you can insert maximum 3 values and 3 values are already there, 40, 45 and 50. So what to do? So what to do in such situation? Students, here you need to split your node. Now tell me, node can be split from middle of the term. Middle of the term we have 45. I am just highlighting over here that we need to do split operation from 45. Now 45 will go one level up. 45 will go one level up to the parent node. One level up to the parent node. But tell me, is there any space still remaining at the parent node? Is there any space still remaining at the parent node? No, because their parent node is already full. Their parent node is already full because parent node contains 35, 66 and 80. Okay, so 45 cannot insert over there until and unless you make a space at that position. So what I need to do is I need to again split, but now this time I need to split root node 66. This time I need to split root node 66. Okay, so what I did, first I want to insert 55 over there. Okay, but there's no space, so I need to split the data, split the node, and 45 will go on the root node. Okay, but there is no space on the parent node. There is no space on the parent node. So again split operation is performed. Parent node's middle term, that is 66, will go one level up. 66 will go one level up. Okay, and now let's see what happens. 66 will go one level up. So now see the situation. On the left side of the 66, students, you may have 30 and 45. 30 and 45. Okay. On the right side of 66, you may have 80. But what about the rest of the values? So just arrange the rest of the values according to the ascending order. Okay. So on the left side of 35, we must have the values that are lesser than 35. middle of between 35 and 45, you must have the values which are greater than 35 but less than 45, that is 40. Now, the values that are greater than 45 and less than 66, greater than 45 and less than 66 are situated on the right side of the 45, that are 50 and 55. Now, on the left side, right side, left of the 80 we have 70, 75, right of the 80 students we have 90 with us. So this is our final answer after inserting 55. Now, students, we have 110, 110. So 110 is greater than 66, greater than 80 and goes with 90. Now, is there any space with 90? Yes. So we can easily insert 110 on the right side of the 90 like this. Okay. So now 110 is successfully inserted. 110 is successfully inserted. Fine. Now let's move towards the next. Next we have 100 with us. Next we have 100. So students, 100 is greater than 66, greater than 80. Okay. So move towards the right leaf node, that is 90 and 110. So can we insert 100 directly? Yes, because we have enough space over there. So just insert 100 in between of 90 and 110 according to ascending order. Okay. So here it is. Just 100 is inserting on the right side or in between of 90 and 110. Now last term, that is 120. So how to insert 120? Now you need to think for that, because 120 is need to be inserted on node 90, 100 and 110. Okay, 90, 100 and 110. But now tell me, is there any space for them? Is there any space for 120? No. So what I need to do is, I just need to split from the middle of the term, that is 100. So 100 will go its parent node. Now tell me, what is the parent node, or who is the parent node for 100? That is 80. That is 80. So students, 100 will just move one level up. 100 will just move one level up and going to be connected with node 80. So here, see, this is the figure. 100 and 80 will just connect it together. Okay. Now on the left side of the 66 students, the values are remaining as it is, but on the right side of the 66 we have 80 and 100. So the values that are smaller than 80 must be on the left side of the 80. So 70 and 75 on the left side of the 80. The values which are greater than 80 but less than 100, greater than 80 but less than 100 must be in between of 80 and 100. So the 90 is in between of 80 and 100. And what about the 120 and 110? So students, here it is, the 110 must be on the right side of 100. Fine. So now just 120. So check 66, right, 100, right, 110. Now 110 has enough space to insert 120. Yes, there is enough space. So we are just need to inserting 120 over there. Fine. Okay. So this is our final answer. Okay. Here it is. So this is B tree of order 4. You can easily say that there are no nodes which does not following the rules of this B tree. Okay. They all contains the B tree properties, like the all leaf node are the same level. Yes. All nodes, all elements in each node must be in ascending order. Yes. Now tell me, the nodes data stored in the whole tree in ascending order. Yes. Now the values which are lesser than 66 are on the left side, greater than 66 are on the right side. Yes. So students, here the all properties of the B tree are successfully satisfied. This is B tree of order 4 after inserting the all data from 66 to 120. Okay. So that's it for today's lecture. Thank you so much, students.